Okay, here we go. So, let's take a look here at this first one. All right, so number 9 here. All right, we're going to look at. So you can see the picture's already drawn for us, which is nice. Okay, the next one we're going to do, there is no picture, so we're going to have to come up with that picture on our own. But let's take a look here at this first one. All right, you can see a lot of like Greek letters here. You got the beta, you got the theta, and you got the, I think that's phi or phi, I think. Okay, phi. I think that's how it's pronounced. I know, right? So I think it is, though. Greek. Anyone taking Greek here?
It's phi.
It's phi. Okay.
I'm not taking Greek.
But you know it's phi. Okay, it's phi. Yeah. Okay. Okay. I gotcha. So the phi. We're kind of adding on to it, I would say. Yeah. Continuation. So let's take a look here. Number 1, in the figure, when phi is 90 degrees, x equals 125 kilometers, and y equals 175 kilometers, what is the measure of angle theta? So I'm going to do this with pencil here because the scenarios are going to kind of change a little bit. So we're told that x is 125. Okay, kilometers. I'm going to write that down there because I didn't leave myself enough space. Y, we'll say, is 175 kilometers. And we're asking, and we're also told that this is a right angle right here. Okay? And so we're asked to find the measure of angle theta. Okay? So given this information, what kind of relationship could we use here to find theta, this angle? Tangent. Okay? Why are we allowed to use tangent in this case? Why didn't we use like law of sines or law of cosines? Because it's a right triangle, right? Okay? Could we have used law of sines in here, for example? Right. So it's like yesterday I said that, for non-right triangles, we certainly can't use Pythagorean theorem, right? We certainly cannot use tangent, sine, or cosine by themselves. For non-right triangles, we can use things like law of sines, law of cosines. But is the reverse? What about the reverse? What if I have a right triangle and I still want to use law of sines, law of cosines? Is that okay? The answer is yes, you still can. Yeah. So if you wanted to here, right, you could use law of sines. It would be a little bit tricky because you don't have an angle opposite side pair that you know. However, we could find the hypotenuse here using our two legs, right? And then we'd have 90 and this side right here, and they could say then, this ratio. So it'd be like sine of 90 over this hypotenuse equals sine of theta over this side right there. And you could go from there if you wanted to. You could, but why do all that work? We can just use tangent. Okay, so let's say we do use tangent here. So it'll be tangent of theta equals, and what will it equal then? What over what? 125 or 175, exactly right. We're going to find the opposite over the adjacent. Okay? And then to finish solving for theta here, what should we do now? What's that? Arc tangent, right? Inverse tangent. Yeah, so we'll say theta is then arc tan 125 over 175. Okay? So type that into our calculators. What mode should we be in for this scenario, you think? Yeah, probably degrees, right? I mean, radians, but we do have the phi given to us as 90 degrees, okay? And so you'll want to keep that consistent. So we'll use the 90 there. Okay? So make sure I turn it back because I was doing some calculus, so I was in degrees. Arc tan 125 over 175. Okay, and we should get theta is approximately 35.538. I'll say there. I'm going to round up. Okay. So this ratio 125 over 175, right? It's positive. All right, and you might be wondering to yourself, Mr. Whitmire, well, when we were doing the law of sine stuff before, you said we had to kind of check there are two angles, right, on our, kind of like unit circle or within the coordinate plane or whatever. For the sine, right, that earlier problem we did, where the sine of that angle gives us the ratio we wanted, right? Well, technically, there's also two angles theta that when you take the tangent of those angles, you get this positive ratio. But where else is tangent positive besides the first quadrant, like this angle we got here? Where else is tangent positive? And quadrant 3, okay? What's the range of measurements of angles in quadrant 3? From what to what? It's between 180 and 270. Would any of those angles make sense in this scenario? No, okay? And so that's why when it comes to these triangles, right, that we're trying to solve, for sine, it makes sense to check both the first quadrant and second quadrant angle, because angles in the first and second quadrant could be part of a triangle. Angles in the third quadrant, like we're doing here with tangent, would never make sense to be in a triangle because they're between 180 and 270. Okay, so that's why we never consider the other, options there. We just keep with the one angle, which is the answer there. Okay. Same thing would be true with cosine, because cosine's positive not only in the first quadrant, but where else? Quadrant 4. And that would be then angles between 270 and 360. Again, way too big for a possible angle in a triangle. But sine's unique because it's positive in the first and second, and so you could get more than one possible answer that would make sense for the triangle. All right, questions on 1? All right, number 2 then. Ship B veered off course. So there's our ship B. Veered off course so that it is no longer directly north of Lighthouse Rock. All right, so no longer directly north means what measure here do we no longer kind of have? The 9-degree angle here, right? We no longer have that. Okay. So ship B veered off course so that it's no longer directly north of Lighthouse Rock. Distance x is now 24 kilometers. Okay, so we'll change that. And then distance y is 33 kilometers. Okay, so we'll change that as well. And theta then, now we're told, is just exactly 38 degrees. And we want to find beta. Okay. So to find angle beta here, could I use tangent again? Tangent of beta equals opposite 33 over adjacent 24. Can we use that? Could I use tangent here? No, why not? Not a right triangle, exactly right. Very, very good. Yes. Right, we lost that right angle because ship B is no longer directly north of Lighthouse Rock, whereas ship A is, well, I guess we still assume, directly east of Lighthouse Rock there, right? So what can we use here then to solve this, to find this missing angle beta here? Can't use tangent. Okay, yeah? Law of sine or cosine, okay? So which one do we want to use here? Why sine? What clues us in? Right, remember for law of sines, you want to start with an angle and opposite side pair that you know. Do we have an angle and opposite side pair that we know here? Yeah, the 38 and the 24. So we'll write sine 38 over 24 equals, and then we're going to solve for beta, so sine of beta over 33, right? Cross multiply and solve here, so we get sine of beta equals 33 sine 38 over 24. Okay. And so then inverse sine there to both sides. We'll say beta is precisely sine inverse of 33 sine 38 over 24, which then, as an approximation decimal-wise, I get like 57.837 if I round degrees. Okay. Now, oh yes, Remike, go ahead.
Is there such thing as an arc sine and arc cos? Because like you write sine -1, or is it just the same thing?
Absolutely the same thing. Sine, I see what you're saying, arc, cosecant, or whatever. Yeah, so sine -1 like that is the same thing as arc sine. I mean, they're the same thing. And you'll see them used interchangeably. I really don't see why, I don't know if there's a reason why sometimes you use arc sine, sometimes you use sine inverse. It's really, they're interchangeable though. So yeah, I never thought of whether there's a reason or not. So there's our answer for beta. Okay. Now, in this case, right, since we're using that law of sines and we're finding this angle first, in this case, actually, if you subtract from 180 here, you get the angle 122. I'll put this like over here on the side. If you subtract from 180 here, you get 122.163 degrees. And technically, that angle would also work in our triangle here. So really, there's like two possible triangles. So angle B could be this or it could be this, right? If you don't believe me, here, let me just show you here. Okay, so again, we said that the ratio we're shooting for is this, 33 sine 38 divided by 24. Let me put my light there. Okay, right? So that's the ratio we're shooting for when we take sine of our angles. Well, if I take sine of 57.837, you can see they're the same. Again, rounding, so we lose some of the accuracy there. But if I also do sine of 122.163, you'll see again the same ratio, again with the rounding off a little bit, okay, because of the rounding there. So in fact, both of those angles would work here. So potentially both are true, all right? Both hold true, but we're going to stick with the primary one right there. Okay, but really there's two possible angles that work here. All right, question?
Is there a way that the second angle comes first, or is it always that the first angle is going to come first in that sense?
You will always get the smaller of the two angles first, I think is what you're asking, right? Because inverse sine, remember, its range is from pi/2 to negative pi/2. So if you have a positive ratio, you do inverse sine, you're going to get a first quadrant angle. So then you'll always be solving for that second quadrant angle to kind of check kind of thing, if you do check. But again, like I said, most of the time our problems, all of our problems we're going to have, they're going to be just one triangle. But just, for the purposes of that. So, yeah. All right, last one here, number 3. The lighthouse keeper sights the angle between the ships as 110 degrees. All right, so now we have new scenario here. I'm going to erase this information away. So the person in the lighthouse has a tool or some sort of device that allows them to determine the angle between the ships is 110 degrees. So where should that 110 go in this scenario then? Yes. Where the lighthouse is, right? Yeah, at 5. I keep wanting to say it wrong now. You guys are correcting me. 110 degrees, right there. Distance x, 93 kilometers now. Distance y, 145 kilometers. Okay, and we no longer have that 38. It doesn't really erase that well there. I didn't do a very good job erasing it, but there we go. Okay, and now we want to find the distance between the two ships. That's that right there, right? We want to find that distance. Okay, can we use law of sines for this? No, why not? We don't have a pair of angle and opposite side that we know, and nor can we find one, right? Nor can we find one, because we only have one angle. We can't use that one angle to come up with these two missing sides here. We just don't have enough information. And so if we can't use law of sines and it's not a right triangle, what's our last resort here to use? Law of cosines, right. Now, gets a little bit tricky here because we have 3 different formulas, but there's no I guess it was kind of like an A, B, and the C here. We could say this is A, that's B, and then this will be like C, okay? So maybe we can do that, right? We can just use the A there, the B here, and the C there to kind of name our vertices. Which formulation of the law of cosines should we use? Should we use the A squared equals 1, the B squared equals 1, or the C squared equals 1? What would make the most sense here? So let's go around. What do you say, Megan?
The C squared.
C squared. Julia, what do you say?
C squared.
C squared. Ramike? Ramike's like, well, I gotta say C squared. No, I'm just kidding. You were gonna say C squared at first, right, Ramike? Yeah. Okay. Yeah, it is C squared. Okay, it is because the C squared formula, all right, has a solving for little c here, and the C squared formula also has cosine of angle C in it, which is the only angle we know. Okay, so that's exactly right. So C squared equals A squared plus B squared minus 2AB cosine angle C. All right. So I'm going to let you guys go ahead and do this one. Go ahead, plug in the information there, all right, and see what you come up with. And again, remember, this is harder than, students find this more difficult than I would expect them to sometimes, okay, because of the arithmetic, I guess. So go ahead, simplify that as best you can. Plug in the information and solve there. And we'll see how we do. Yes. Oh, I'm sorry, yeah. Yep, you're welcome.
Use the size of A. So you said 90 A.
Correct, because it's opposite angle A. Yeah.
But what if for cosine C, do you use 110?
Because angle C is 110, right? If you notice, we designated the lighthouse to be point C because it was shift B, so we just made that B. And shift A, so we just made that A. I'll give you like 30 more seconds here. 30 more seconds to finish your calculations.
What do you get?
Okay. 30 more seconds. No, less than 30 seconds. Okay, did anyone get 197.226?
Yes.
You did? Good. That's right.
The 227.
Okay. If you got 38,898, you forgot to square root. It's C squared equals. Yeah. Mr. Witt's seen it all, you know. Okay. So that's the final answer there. Don't forget the square root at the very end of that sum, okay, or the expression, the quantity there. All right, and of course, use units, right? We're in a context, so units are more important here, okay, because we're in that context. So there's the idea. All right, questions on any of that? Ready to move on to the next one then? No? No wait?
Thank you.
You're welcome. All right. Let's move on to this next one, which is more interesting, I think. All right. Because we have to make the picture ourselves. Okay. So, we've got a fishing boat heading due south, and it's about to turn towards one of two docks. Okay, dock 1 is located at a bearing of south 55 degrees west of the boat. Okay, dock 2, which is 10 kilometers due east of dock 1, has a bearing of south 32 degrees east of the boat. Round out calculations to 3 decimal places, 7 points. Okay, so we haven't talked a whole lot about bearings, all right, but we're going to be fine here. All right, the fishing boat is heading due south. So we're going to draw kind of like location. We're going to draw this diagram here. The fishing boat is heading south. So that means the direction, we should probably put the fishing boat kind of located where in our diagram here? On top, because we're heading south. And all of our bearings are south of the boat. So you're going to draw your little boat there. There it is, okay? There's my little boat. Fishing boat. Okay. There are two docks. Dock 1 is located at a bearing south 55 degrees west of the boat. Okay? So in other words, there are two directions here in the bearing because the first direction is kind of like where you want to face initially. And then 55 degrees is the amount you rotate and then west is the direction in which you rotate. All right? So south, so imagine south, a direct south line would be like down here. Okay, like that, right? That's directly south, right? We're just going to say it's below the boat, right? North, south, east, west. Never eat shredded wheat. Never eat soggy waffles, however you want to remember that, okay? All right, however you remember that.
Never, ever steal warts.
Perfect.
Steel warts.
Steel warts. Yeah, you don't want them. So we're going to go then from that south direction orientation. We're going to rotate 55 degrees west. And so to the west will be which direction from our south line here? Left. So we're going to rotate west some amount here. And this angle right here is 55 degrees then. Okay? That's a 55 degree angle right there. Okay? And that is where dock 1 is located. Okay? Dock 1. Dock 2, which is 10 kilometers due east. So here's dock 1. Dock 2 is 10 kilometers due east. So due east will be which direction from dock 1? To the right. And directly right, right? So horizontally to the right. So we'll kind of like draw like... And there's dock 2. Okay, I know it's supposed to be like a top-down picture here, and I'm drawing my water like you're seeing from a side view, so this may confuse you. But anyway. Okay. My dock is not very... That looks like a mess. But anyway, you get the idea. That's the dock. All right. Then that's 10 kilometers due east. All right, and then so dock 1 has a bearing south 32 degrees east of the boat. So that 32 degree angle, is it going to be here where the dock is, or is it going to be up here where the boat is? The boat. Who is doing the bearing is taken from the boat, right? Bearing of south 32 degrees east from the boat, or of the boat. So south, but now we're going to go 32 degrees east from south, which means we're going to go which direction? To the right. And you can kind of see it, right? We kind of naturally have to go to the right here in order to get to the dock. So this is then 32 degrees. Okay. So there's our diagram. Label all information that's provided, right? So we did. This is like half an hour right here. Yes, Ramika?
Can you explain like the bearing thing of 32 degrees again?
Sure. So again, the first direction that you're given, whoops, I'm off the screen. The first direction that you're given there is south. So that's where you want to start facing. You start facing south. Okay? And then you're supposed to turn 32 degrees in the direction of the second direction. So 32 degrees east. Okay? So then south, and then 32 degrees east would be to the right there in this easterly direction. Okay? So there's our picture. If you can get that down, like you've got half the battle right there. Now, letter B asks, which dock is the boat closer to? How much closer is the boat to this dock than to the further dock? So, in order to determine which dock is closer to the boat, what distance here are we trying to find? What lengths or what sides are we trying to find here? So, yeah, Julia?
The opposites of dock 1. That side.
Yeah, this side right here, right? Yeah, and this side right here. Exactly right. Okay. So, how can we go about doing that? So, yeah, Ramike?
The split time in half, that would be 5, and like try to find the length of the line that's those channels are sharing, and then do pattern and
Okay. So let's. Oh, Hayden, what do you want to say?
They're both related.
Okay, so we can agree for sure we have right angles right in here and here, right? From that south, because that's a direct north-south line, and then that east-west line is also there too. Can we assume that this 10 gets evenly split between these two sides here? No, why not? Why can't we assume that here? What's that?
You don't know the distance between the boat and
We don't have enough information here. In fact, actually, I would say we actually have enough information to say that they're not going to be necessarily the same, that they won't be the same kind of thing. Why? Well, because if you think about it here, if that's 55 degrees, and we can figure out what this missing angle is now because of the right triangle there. So these two angles adding up subtracting from 180, there's no way that's going to be 32. So these are not going to be congruent triangles, and therefore we wouldn't expect these to be the same measures there. Okay? So, but good thinking, Ramike. But we're on the right track, though, now. So now we have this information. We can find the missing angle. Well, let's see here. We can find the missing angle like here, for example. What's this angle going to be right here? Yep, so 35 degrees, right, I think is what that ends up being then. Okay, and then what about this angle right here? So, yeah, I think it is 58. Yes, that's right. Mm-hmm. Very good. All right, so now we've got some more angles in here, but we still haven't found the distances between the boats and the dock, though. The boat and the docks. You sine? Sine of what? Sine of 87? Sine of 87 over 10. Ah, so we have to use law of sines here. Right. So we use the right triangles to help you get these missing angles in here. But now this bigger triangle, right, it's not a right triangle, but we do have an angle, 87, and an opposite side, 10, that we can set up there. So we can say, yeah, sine of 87 over 10 will be in the same ratio as, what's another one we could do here? Sine of 58 over, and let's just call this maybe like A, okay? And we'll call this B here then. Okay, so over little a. Like that. Okay. So this is complex, right? First we had to make sure we drew the diagram accurately. Then we had to see that the big triangle that we created is actually split into two smaller right triangles, use the two right triangles to get missing angles, then zoom back out to the big triangle here and use law of sines to solve for missing pieces. So this is not, simple, I would say, right? There's a lot of moving parts here that we had to get through in order to get to this point. But now that we're here, right, we can just cross multiply and solve, get that A is 10 sine of 58 over sine of 87. Off the screen. There we go. Okay, and you can just type into our calculators. So I get about 8.492. Okay, and let's do the same thing for B here. So for B, I'll still use the sine of 87 over 10. We'll now say sine of 35 over little b. And so B is exactly 10 sine 35 degrees over sine of 87. I get about 5.744. Okay, these are in kilometers, of course. Okay. So, which dock is the boat closer to? Dock 2 is the closer dock. How much closer is the boat to this dock? Right, so what do we have to do to find how much closer it is? Subtract, right? So we'll do 8.492 minus 5.744, and I get 2.748. Okay, so if this was an emergency, you want to get to the closest dock, you go to dock 2. All right? Speaking of emergencies, letter C. A dock worker spots a swimmer hanging onto a buoy that is 3 kilometers away from dock 2. The buoy has a bearing of north 18 degrees east from the dock. How far would the fishing boat have to travel to rescue that poor swimmer? Okay. So there you go. Just like that movie with that girl,
In the shark.
that shark thing. Yeah, she was hanging to a buoy, wasn't she? Yeah, well, here it is right here. It's all in a math problem.
Wait, did she die?
Yeah,
Okay.
Spoiler alert.
it's the beginning of the movie.
No, she didn't die in the end.
What would happen in the whole movie?
Was the shallows?
Yes, the shallows. Yes, yes. Okay. You don't have to tell us how if she survives or not. Spoiler alert.
Whisper it really loudly so I can.
Right. And then Hayden can spoil it for everyone else.
Yeah.
Oh, she dies! Oh, I'm sorry. All right, anyway. All right, letter C. So, the buoy has a bearing north 18 degrees east from the dock. So now the observer here is the dock, and we're going north 18 degrees east. So north from dock 2, and then 18 degrees east is going to be like this way. 18 degrees there, okay? North 18 degrees east, okay? And that's where that swimmer is on the buoy. And I don't really have a good way to draw the buoy, so we'll just...
A circle.
Oh, okay, I see what you're saying, like a donut-y kind of thing, and then... Okay, there you go. There's the swimmer attached to the buoy.
Where's the swimmer? No, but where? Oh, the square is the swimmer. Oh, thank you.
There's the swimmer.
It looks like a really dumb bicycle. Without like the back, without the back tire.
This flashbacks to high school art class. No, just
Dumb
kidding.
bicycle.
All right. So anyway, so now the dock worker spots a swimmer hanging onto a buoy that's 3 kilometers away from dock 2. So we know this is also 3 kilometers here. Okay. How far would the fishing boat have to travel to rescue the swimmer? So from the fishing boat to the swimmer there. Okay, we're going to find this distance right here. Okay, so we have to add on to our diagram there. Okay. So, yes, Ramike.
So for like, well, if we have this in the benchmark, will we still put that diagram on?
Would you add to it, you mean? I would suggest you do. It's not necessary, though. You can, like, redraw it down here if you want to with just the additional information. But I suggest you do because you actually need some of the earlier information that we have already established to then help you solve this problem, okay? So how should we proceed here? Okay. What's some information that we're going to... So, okay, so, yeah, Megan?
We know what little b is from the second problem.
Right, we know little b, so we have this side, and we have this side, and we want to find the opposite side here. So all we really need then is this angle, the full angle here, and we'll be able to get, using law of cosines, the opposite side. So, I would say we can't say that for sure, no, but, Julie, you want to say something?
Can't you just, for the getting the rest of the angle, wouldn't it just be the opposite of the 58 going back to like geometry? So it'd be the 32 because it'd be a 90 degree.
So right, okay, so this is still east-west, right? This is still running east-west here. This is running north-south. And so what angle is created right here? It's a right triangle, a right angle, right? A right angle. And so like Julie was saying, so if that's 58, then we know this is going to be 32. From here to here. Okay, yes? And so that gives us then the full angle of 50 degrees, right? So 50 degrees is that angle. All right. So yeah, we don't know. We're trying to find this side. So we have this length, which we did from little b, right? We have little b. We have this side right here, which is 3. We have the angle between them, so it's side angle side. That's law of cosines we're going to use now, okay? And you want to use the version of the law of cosines. And again, you can like label things if you want to here, but we're going to use the version of the law of cosines where we're going to use cosine of this angle. And so the opposite side here, right here, that's the unknown. So it's going to be, how you wanted to designate these, it doesn't really matter. But it's going to be, our unknown angle is going to be, you know, gosh, I don't even know what I want to call this. Let's just call it, I don't know, I'll say distance D there maybe or something like that. It's going to be the B, which is 5.744 squared, plus then the 3 squared minus 2 times the 5.744 times the 3 cosine of the 50-degree angle there. Okay, just like that. Question on anything? Yes?
I was just going to ask you, couldn't you do just the sine because you can assume that with the other angle you could get the 58?
Let me think here. So like you're saying use law of sines
Because for the top...
right here. We don't know that's a right angle up there though.
No,
Oh.
the one by the boat.
Over here?
Yes.
Okay.
And then
How can we find that one?
it would just be, so you know that one's exactly the north-south.
This is north-south, but we don't know this one's east-west. It looks like it is, but we're not sure. We can't be sure because we're not told that. Here, this was told. We are east-west right here, so these are going to be right angles, and these will be right angles. Yeah, good thinking. And I drew it that way. You know, it just looks that way. Okay, yeah. Questions? Yes, Ramika.
Are we using 5.744 and 3?
So this is our triangle right here, right? We're trying to find this length, so we need to know the other two sides. So the 3 there, and then this was the B that we saw for earlier. No dumb question. Okay, there's a lot of stuff going on here. Like honestly, Ramike, honestly, I mean you might feel that way, but really there's a lot of stuff going on. This is not an easy problem. It's very complex. You make an error early on, and it's going to carry through too. So you got to be careful when you're doing a problem like this. Anyway, let's go ahead and solve this real quick here. So we get 5.744 squared plus 3 squared minus 2 times 5 times 3 cosine 50. All right, so I get about 4.454. Okay, make sure I did this right here. Yep, I think I did. Yep, 4.454. Questions on any of that? No? Okay, I want to show you one more here real quick. I'm sorry, I didn't want to take too long here. Okay, I'm just going to flip over to the back and just show you a side scenario. And we'll just set it up. I think you guys can go from there. Okay? So here's just how you do a law of cosines with side. So given a side, okay, given SSS, and let's just say here we've got A is 7, B is 10, C is 4, excuse me. Okay? We're going to find the missing angles. Okay, so we'll draw a little picture here. A, B, C, not drawn to scale. So side A will be 7, side B is 10, side C is 4. Oh yeah, definitely sure. Okay. Which formula of the law of cosine should we use here? So really, any of them are going to work here. Okay, because you have all 3 sides, you can kind of pick and choose which angle to solve for. What you want to do, though, in a situation like this, and it has to do with making sure that we get the right answer and stuff like that, always solve for biggest angle first. Okay, and this will help avoid like getting different answers and stuff like that. Solve for biggest angle first. Okay. So the biggest angle in this case is going to be what? B. So we're going to use the B squared equals A squared plus C squared minus 2AC cosine of capital B formulation. Okay, so we'll plug in all the stuff that we know. B, little b is 10. Little a is 7, little c is 4, minus 2 times 7 times 4, cosine of b. Just plug in information there. And then to continue solving here, okay, to continue solving, this is where students tend to make the most errors in this one, okay? The other one, yes and no, but this one is more, it's more mistakes I see. Okay, again, students tend to put all these numbers together. Can't do that because it's 2 times 7 times 4 times cosine. So you can put the 7 squared and the 4 squared together. You can put the 2, 7, and 4 together because they're all being multiplied, but don't put them all together, okay, because it's just cosine times the 2, 7, and 4 there. So anyway, let's do the 7 squared plus 4 squared. Okay, so 65. That's equal to 100. Minus, and then 2 times 7 is 14, times 4 is 56. Okay, how should we continue to solve from here? What should we do to both sides now? Subtract 65. And then divide by negative 56. Okay, and then cosine inverse. It's approximately 128.682 degrees. Okay, I didn't have enough space to put all my decimal places in there, but you get the idea. All right. At this point, then, what can we use now? Law of sines. Law of sines. Okay. So, there we go. All right. Questions on any of that? All right. Well, then what I've got for you here is a few problems from the book. This will be on page 441. Okay, and they'll be numbers 7, 9, 19, 31, 47, and 52. These are all, again, calculator active. Also, I put up a 10 marks too, 2 10 marks, okay, just for some extra practice and stuff, so please check those out.
So will the written response questions be on the quiz tomorrow?
There will potentially be like,
One.
there'll be potentially like word problems and stuff like that, okay? So, I mean, you could see something like this potentially, but, I mean, it's going to be more along the lines of stuff you see from the homework, I would say.
Okay.
Stuff from the homework, I would say. So, alrighty. Yes. No.
So can you tell me the set on Monday?
I can. Yes, go ahead. Yes.
Can I use the restroom, please?
Yes.
Thank you.
My warm up for last Friday. I never turned it in.
Okay, thank you.
So.
Gotcha.